So this is homework number 12.5, question number 4, and this is a system of linear differential equations. And in order to solve this function, first thing I want to do, just to make it a little bit easier for me to read, is I'm going to put all of our variables on one side. So we got x prime minus 3x plus 3y is equal to 0, and our y prime plus 3y minus 6x on the bottom. Now that that's out of the way, I can clearly see what my two functions are without having to worry about what they're, if they're positive or if they're negative. We can see completely what they are. And now we're going to want to rewrite these in terms of d. So, d script, but I'm just going to say d for now because for simplicity's sake, the difference is d is understood to be a function of x, like a derivative of x, but d script is a derivative of t, and since both x and y are both functions of are both functions of t, we can just state d for it and be perfectly fine. So when you do put them in terms of d, you'll get d minus 3 times x plus 3y is equal to 0, and d plus 3 times y minus 6x is equal to 0. And now, first one I'm going to do is I'm going to get rid of the x's in order to solve this equation. So I'm just going to write here for the x's, meaning I'm just going to get rid of them. But to do that, we have to multiply both of our functions by something in order to make our x's cancel when we add them together. And for the top one, it's going to be 6. And for the bottom one, it's going to be d minus 3. Now, when you do this, you have to make sure you multiply it into every single function, because you can't say, okay, I want this to be 6, blah, 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 6 times d minus 3 times x plus 3y, because that would be wrong. That just algebraically is not true, and you cannot do that. But once you multiply it out, you will find that our new equations are going to be 6 times d minus 3 times x plus 18y is equal to 0, and our other function will be d plus 3 d minus 3 times y minus 6 d minus 3 times x is equal to 0. And now you can clearly see that when we add them together, both of our x values will cancel. So adding them together, we find that our new single function is no longer a system of equations. It's now going to be a single function. We will get d plus 3 d minus 3 times y plus 18y is equal to 0. Now we are going to want to start solving for y. And in order to combine these two, we got to FOIL out our d plus 3 and our d minus 3. In doing that, we will find that it'll be d squared minus 9 times y plus 18y is equal to 0. Now we can just, since they both are the same kind of variable, we can say that negative 9 plus 18 is just going to be positive 9 d squared times y is equal to 0. Alright, cool. Now we're going to set it into our characteristic equation. And when we do that, we can see that it's going to be m squared plus 9 is equal to 0. And from there we can see that our m is going to be plus or minus 3i. Don't forget your I, because it's going to be an imaginary number, because you're going to be taking a square root of a negative, so it's an imaginary. And therefore we can say our fundamental solution is equal to cosine of 3t and sine of 3t. And from that we can say our general solution for x is going to be x is equal to c1 cosine of 3t plus c2 sine of 3t. Okay, cool. Now that we found our general solution for x, we're going to find our general solution for y now. So I'm going to write up here for y. And from this, we're going to say that for this one, we're going to have to bring back our terms of d functions. And in doing that, we see that it's going to be d minus 3 times x plus 3y is equal to 0. And d plus 3 times y minus 6x is equal to 0. Now, in order to make our y's cancel out, we're going to multiply the bottom by negative 3 and the top by d plus 3. And when you do that, you will find that our new equations are going to become d minus 3 d plus 3 times x plus 3 d plus 3 times y is equal to 0, and it'll be negative 3 d plus 3 times y plus 18x is equal to 0. Adding them together, we'll find that our singular equation of these is going to become d minus 3 d plus 3 whole thing times x plus 18x is equal to 0. And now we can see something very interesting here. It is actually equal to the same equation that we had for our other equation, which is the only difference is going to be our x's and our y's. So making life easier and saving time, we know that our m is going to be equal to plus or minus 3i, and that our general solution for y is also going to be y is equal to c3, it's not the same constants as the other ones, sine of 3t plus c4 cosine of 3t. Now we have both our x and y value, our x and y functions. So I'm just going to put a break in the page so that we can focus on now solving for the IVPs. And what do we know about our equations is we know it has been given to us that x prime is equal to 3x minus 3y, and our y prime is equal to 6x minus 3y. We also know initial values. X of 0 is equal to 4, and y of 0 is equal to 3. Those are going to be important. So now we can see that our x is equal to c1 cosine of 3t plus c2 sine of 3t. Taking the derivative of this, we can see that x prime is going to be equal to negative c1 sine, negative 3c1 sine of 3t plus 3c2 cosine of 3t, and our y is, we know, is c3 sine of 3t plus c4 cosine of 3t, and we know that our taking the derivative of that to find y prime, we can say that y prime is equal to 3 times c3 sine 3t plus negative 3 c4 sine of 3t. I'm sorry, this isn't supposed to be a sine. This is supposed to be cosine of 3t. So now we have figured that out. First thing we can do is the most obvious solution of them all is just take our x function. X is equal to c1 cosine of 3t plus c2 sine of 3t, and we can plug in our x of 0 is equal to 4. In doing that, we find that 4 is equal to c1 cosine of 0 plus c2 sine of 0. Sine of 0 is 0, so that just becomes 0. Cosine of 0 is 1. So, therefore, we can say that c1 is equal to 4. Next thing is also just as obvious. Do the same thing for y, and we will find out that 3 is equal to c3 sine of 0 plus c4 cosine of 0. Of course, sine of 0 becomes 0 again, and the cosine of 0 becomes 1, and therefore we can say our c4 is equal to 3. Now, we have solved for our two problems, and we've kind of hit a roadblock. Because how are we supposed to solve for C2 and C3? Because we don't have any more initial values. Well, this is where taking the derivative of our problems is going to come in. To solve for the C3 and C4, what we are actually going to do is a little trick. Since we know what x prime is, we're just going to put x prime here and say that is equal to negative 3 times c1, which we discovered is actually 4. So we're just going to say negative 12 sine of 3t plus 3 times c2 cosine of 3t. Now, we also know, because it was stated that x prime is equal to 3x minus 3y. Since we also know that, we can set the equation times 3x minus 3y. Now, what we can do, we know what our x value is, because that's what we originally solved for, x. So we're going to take that, plug it into here, and we'll find out that it will become 3 times c1, which is 4, so that's 12 cosine of 3t, plus 3 times c2, we have to find that, sine of 3t, minus 3y is equal to negative 12 sine of 3t plus 3 c2 cosine of 3t. What we're going to do here is actually solve for y. So we're going to bring this entire section over to the other side, and we're going to divide everything by negative 3. In doing that, we will find that y is equal to 4 sine 3t minus c2 cosine 3t minus 4 cosine of 3t minus c2 sine of 3t. Now, because we have our initial value, y of 0 is equal to 3, we can take that and plug it into our new problem and say that 3 is equal to sine of 0 is 0, therefore the whole part becomes 0, minus c2 cosine of 3t is 1, so we'll just put 1 there. Or, sorry, cosine of 0 is 1, so we'll put a 1 there. Minus 4 cosine of 3t. Cosine of 0 is 0, therefore it's just 4. Minus sine of 0 is 0, therefore the entire thing becomes 0. Now we have to add 4 over to the other side, giving us, excuse me, this is supposed to be a positive 4. We have to add 4 over to the other side, or subtract 4 over to the other side, giving us negative 1 is equal to negative c2. And therefore our c2 is equal to positive 1. Now we have that one solved, we have to solve for c4. To solve for c4, we're going to do basically the same thing except with the other equation that we were given. We're going to use our y prime value instead of our yx value. So we'll say y prime is equal to 6x minus 3y, which is also equal to 3 times c3, we don't know what that is yet, cosine of 3t minus, we know what our c4 value is. Our c4 is equal to 3. Therefore, we can say that it'll be negative 9 sine of 3t. Now, we have to solve for x, and to do that, we are going to need to plug in what our y value is. This whole equation, our y value, and we got to plug that in for y and solve for x. So we'll say 6x is equal to 3c3 cosine of 3t minus 9 sine of 3t minus 3y. We're going to plug in our y. That'll give us negative 3c3 sine of 3t plus c4, we already know, we said it was 3, therefore it's negative 9 cosine of 3t minus our 9 sine of 3t and plus our 3c3 cosine of 3t. Whole thing is equal to 6x. Now, we can divide by 6, but in my opinion, it's a little bit easier to go ahead and use our equation given to us where x of 0 is equal to 4. And we're just going to take 4 and multiply it by 6. And that would give us 24. And then plugging in 0 for all of our t values, we'll see that it becomes 3c3 times 1, because cosine of 0 is 1, minus 0, sine of 0 is 0, therefore the entire thing is 0, minus, again, 0, same reason as before, minus 9, cosine of 3t is 1, so therefore it's times 1. So now we have, we're just going to clean this up a bit and get 24 is equal to 3c3 minus 9. Excuse me, plus 9. I don't know why I have that as a minus there. But so now it's plus 9. So we're going to need to subtract the 3t to the other side. Sorry, this is plus 2. I don't know what I'm thinking right now today. When I forgot to get rid of the negative when I added it over to the other side. I apologize for that, but that explains why I had a negative 9. It's supposed to be a positive 9 here. Now you have to subtract a 9 to the other side. That would give you 15 is equal to 3c3. Divide both sides by 3, you'll find that c3 is equal to 5. Now we have all of our constants. What we can do is we are just going to restate what our x and y functions are. So our x function, our general solution is going to be x is equal to c1 cosine 3t plus C2 sine of 3t, and our y is going to be equal to C3 sine of 3t plus C4 cosine of 3t. So that's our general solution. And since we found all of our c values, we can say our particular solution is going to become x is equal to C1 we said was 4 cosine of 3t. And our C2 value, if we look here, we said it was equal to 1. So our C2 is going to be, we can just ignore C2 and say it's sine of 3t. Y is going to say C3, which we found to be 5. So it becomes 5 sine of 3t, plus our C4 value we said was equal to 3 cosine of 3t. And that is the solution for homework 12.5, question number 4.